Hello everyone and welcome back to Stationeers. Right, we need to wait for these to grow before we... Okay, this one is good to go, but I don't really want to leave these unattended. I want them, all of them, to be growing before we leave, and this one is still growing. It should be any second now, so you know what? Let's just quickly go downstairs and print out what we need for this episode, because hopefully in this one we will manage to fix up everything we need to fix up for the water generator. So for that one we need some radiators, medium ones we need Invar. I believe that is this one. There we need at least 2, maybe 3 of them. In fact, preferably should be 3. Right, we don't need liquid pipes, I believe. That should be okay. But anyways, the problem we are facing right now is that yes, I have dumped a lot of hot water into the base without cooling it down, and I was assuming that the cooling system will be able to handle it. Apparently not. We need to increase the cooling capacity of the system, so that is what we will try to take care of today. Anyways, we have 1 radiator in here. We need 1 more after this one. So that's 2 and 1 more. After this, we need an active vent. An active vent, that's fine. While that radiator is printing, I will check on the plants once again. There you are, finally. Okay. Let's just replant, and now we have 3 times as much oxygen generation, not counting the generative drift, but more or less 3 times as much. Anyways, this one is good to go, and after this one we also need a liquid pipe analyzer. This one we need electrum. Oh, I believe this one is running a bit low. Yeah, 14 grams. We might need to go out fairly soon to bring in some more. So one of these, and I think, yeah, let's just print out a couple of extra piping as well. So pipe, this one, I believe the insulated piping will be enough for whatever we need. We only really need 3 uninsulated piping anyways, but might as well print out some extra. Anyways, that will be enough. So there is that, there. Anything else? So we have the... Did I print out the analyzer? This one doesn't have anything. No, No, I don't think I printed it out. Okay, so analyzer, this one of these. Right. So active vent, the 3, oh right, and we also need a couple of steel sheets so we can actually weld up the radiators, and I think that will do it. Right. Okay, so we will increase the radiator capacity of the cooling system in the old base, so you know we can manage the heat a bit more, and I will also automate the water generator in there, so we will stop generating water at some point and give the base a bit of time to, you know, take care of the excess heat. So anyways, let's start with the cooling first, which we will start right here. So okay, I didn't pick up some steel frames, but thankfully we had one. That will do, and the 3 radiators will go on top of that. These, yeah, they are right on top of each other, but I think they should still work quite alright. It's not as good as if they were spread out into different cubes, but it will work. Maybe at some point I will try to spread them out a little bit, but for now this will do. So there, they are good to go. Just hook them up, just like so. I don't think we need to hook up the output, or okay, technically this is the output, but I don't think we need to circulate the gases, so this one should do it. So now this one is radiating a lot more, good. And next up, I want to increase the input of this one. For that, we need to turn this off. So this one is using the one of the devices for this one, that's fine. And the other one has no device set, good. So for that one, we will use that one for this active vent. You can go that way. Oh, right, and we need some extra piping for this one as well. So good thing I printed some extra there and hook up there. And yeah, we will need to take this off as well. Right. So as you might have expected, we will increase the pressure on the input and that will increase the throughput, and we will have a lot better CO2 input into the base. Anyways, we also need to hook up the power. Good, and obviously venting in. And now we need to change this code, so you turn off for a little bit. Laptop out, this one comes out, import the code, edit and pause. So we will move, I think, yeah, we need to move the temperature checks to the output now. That way we can still monitor the outside temperatures. So we need to move this one, and I will move it to the very end of the code. Here, we don't need to have the input temperature check anymore because that will be coming in from the active vent, so it's fine. And we only need to operate the on-off here. So this line is no longer needed, and that's fine. But to save on the power a little bit, I suppose we can only operate the filtration if we have any kind of pressure on the input. Yeah, you know what, let's do it. So Control C, Control V. We need an input pressure as well. Unfortunately, I was a little bit messy with this code. Let me see. Just copy this one. No, copy this one instead. Let's just use register 8. 8. We haven't used that one before. So input pressure. So use this one, the input, right? And only operate if we have any kind of gases in there. So set greater than 0. So if the input pressure is greater than 0, then set it to 1, and now we can have the end. So on, off, this one goes back to the output pressure. And so if the output pressure and the input pressures are valid, then you can operate it. So that should be okay. And now we need to make sure that we only fill this place up if it is cold enough outside. And also, tell you what, let's play it safe. I don't want to install a liquid drain on this, so let's just have a set. All right, we need to set the vent as well. So alias vent D1, and we want to set the vents. I believe it is pressure internal. Yeah, that's it. Let's just set it to 5 megapascals. At that kind of pressures, the pollutants should not condense out at nighttime temperatures, so it should be okay. We should not have any kind of condensation in this pipe. So set vent pressure internal, that should be okay. And now we are load the temperature input, but not from the temperature input. We need to have the output, but on the waste, so output 2. I suppose the input temperature is basically the same still, so it's fine. So set less than SLT. So if the input temperature is less than Let's just go for 130, so we are as close to the ideal temperature as possible. I believe that is 403, because 270, yeah, 403. And use that to operate. Here we can set the on off and set the vents on to the on off register. Okay, so we set the pressure tolerance of the internals of the vent to 5 megapascals. That will prevent any kind of condensation, but the throughput will still be increased a lot, so that's great. Now we are checking whether or not we have any kind of pressure on the input. If there is none, turn the filtration into idle mode. That's great. Also, we are checking the output pressure as well, so we don't overpressurize. I suppose we can set this to 10 megapascals, so we have a lot more heating capacity, or, you know, heat energy capacity that we can dump heat into. That's fine. Although I suppose, yeah, 5 is okay. And here we load the output, the waste output temperatures. So basically we are monitoring the outside temperatures. If it goes above 130, we shut off the vent, and that should do it. Okay, confirm. Export the code, but first we need to set the vent as well. So this one, active vent. On this network we only have one active vent. Yeah, it's fine. Okay, I think you can go back. So active vent, the coolant light, yeah. Okay, don't stash away the laptop just yet. So the code is overwritten. Now you can go back, and now you can turn on. And it is set to 5 megapascals. Okay, obviously right now it is too hot in this pipe, so it will not turn on. It will only do so if this one is cold enough. Okay, I think we have increased the cooling capacity of the base quite a lot, but we are still dumping a lot of hot water in there, and that is not ideal. Right. Now, we can do this a couple of ways to automate the, well, basically water generation. I think the easiest way of doing that would be to simply add the checks to this chip. Now, I have been testing different kinds of ways of doing this. Originally, I wanted to have a housing here. It would receive the data from this side and power from that side, so it would always have power, and it could operate the different devices on this network. Unfortunately, my original idea was to basically operate the transformer from this side. But as it happens, the transformer can only receive data from the input side. And we have a storm incoming. What time? It is... oh, okay, plenty of time. So, right, as I was saying, unfortunately the transformer only receives data from that side, not from this side, so we cannot operate it through a logic through this network. Which means if we wanted to do this from the inside, we would have to bring data from this analyzer into the base, but this one is already on this network, so we'd have to install another one, and that is a bit much. So tell you what, let's just install a pipe analyzer right here. That will do. You can turn on, if I can reach, that will do. There. So hook it up. Yes, I know I did it through the window, but whatever. There. Good. So now we are reading the contents of the base liquid pipes. So all we need to do is, if we have more than enough water in the base, right now we have only 3 liters, let's say, I don't know, 20 liters, then we want to shut off the water generator. The most ideal way of doing this would be just to shut off the transformer, but as I have said, we cannot operate it through this side. So what I will do is shut off the combustor. That will shut off the water generation basically completely. We still need to empty out these pipes, but the reason I want to do it this way is because we need to make sure the sensitive pipes are kept at safe levels. For example, this one, we don't want to have any kind of condensation in this one, so we need to make sure that this one gets emptied out, so these guys need to be running, and we need to make sure we don't overpressurize these pipes either, so this one needs to be running. The easiest way of doing this is to shut off this one. Basically, if this one has nothing to do, it will be idle. If this one has nothing to do, it will be idle, right, like right now. So they will only consume, I believe, 10 watts or something. The biggest consumers will be the evaporation chamber and the housing. They are 50 watts each. So tell you what, let me quickly pick up the code from this one. Import, you can go back, and let's just go inside and take care of the code while I vent out the waste. Also, before I forget, this one there. I've been meaning to pick it up for a while now. Okay then, so open the waste canister, that's fine. I suppose we can pick up some oxygen while we are here. There, and we can strip down. Good. The reason we need to do this, by the way, and thank you for telling me in the comments, right now the base, you might have noticed that it is 88 kilopascals, so we are not really taking in any excess CO2. And that means that we are not skimming the oxygen. We only skim the oxygen if the base is above 90 kilopascals. So, and this one is empty as well. Fine. Let me quickly... just large battery is fine.
Incoming.
So, as you can see, we have almost 60% of oxygen in the base. It should be 20%, so we are not skimming the oxygen.
Incoming.
And yeah, as soon as we fix the CO2 input, that's going to be better. The biggest problem is that this pipe is too hot because we are cooling the water. So if we automate the water, that it will stop at some point, this guy can catch up and it will be fine. So let's fix that real quick. We have the code from the outside chip, pause, and it should be a relatively simple check. So, right, if it is greater than 0, in that case it is less than. So, if R0 is less than 20, set it to 1 and use it to turn on the H2 combustor. But if it is above 20, this one will be 0, it will turn off the combustor and that should do it. Right, confirm. As far as I can tell, this should do it. So right now we have 3 liters of water in the base. The only way to do this is to... well, I suppose we can do a smooth test. Yeah, we just need to set this one to 3 liters for now. If it works, we can set it back to 3. So confirm. Anything else? The storm is still 5 minutes away, so we have plenty of time to make the checks. Also, I should be drinking some water. So, if I overwrite this code, the combustor should turn off. Let's take a look. So there, export, and it did not turn off. It is H2 combustor. Did I name it correctly? Edit pose. Set patch name. I did use the correct hash. Yes, I did. Let me see. Device hash, name hash, logic type, register. Oh, branchless done. Sorry. Yeah, my bad. There we go, now it shuts off. Okay, so we know it works, so we can set the threshold to 20 liters now. So you can go back to 20, confirm. You can export, you can go back, and it should turn on. There we go, okay. And by the way, why is the big delay? It should just be a simple yield. Yes, it is, okay. Oh well, it works, that's what's important. Okay, so as soon as we have 20 liters in the base, the combustor will shut off. We will let the remaining water trickle through, and we will stop making water. We will still have quite a bit of power usage through these two, but other than that, everything will be fine. Okay, so it's not too bad. We can go inside, and I think we should be okay now. And we still have 75% power on the rocket. Okay, let me quickly strip down. And there and there. And the storm will be here in about a minute. We might need to, might want to go to the new base fairly soon. Let me just quickly take a drink. Take a bite to eat, and I will leave immediately. Okay, I was in a bit of a hurry, but we managed. So, let's take a look at the plants first. They should be doing alright at this point. And yes, they are. Moderately well. They were thriving a little bit ago, but now they are back to moderately well. They will be okay in a second, it's fine. The water in the base is 6.6 liters. Would be better, I suppose, but it's fine. And the storm is here. Okay, well, tell you what. What if we... I don't know. I suppose we can work on the local water generation for now. We can go downstairs and let's see what we need to print out. So, I think I will try to emulate what we have on that base, more or less. We will need at least 3 atmospherics. So, atmospherics, we need at least 3 of these. Also, gold is running a bit low. At this point, we might need to go out and mine enough that we can have basically enough resources for every single one of these machines, and maybe only juggle the alloys. But obviously you can't do it during a storm. Anyways, so we need 3 atmospherics for water generation. 1 for the combustor, 1 for the voltage filter, and 1 for the water filter. Obviously we'll get the oxygen straight from the base. Speaking of, it is almost 6%. Most of it is coming from the trader, obviously, but we are still making progress. Anyways, that will do. And this time around, I think I will just use AC units to cool this. Yeah, I think that whatchamacallit, evaporation unit was not really all that effective, so yeah, let's just have a two-stage cooling setup before we move it into the base. So we need 2 more of these. In the meantime, we can throw down these. We can put away the lamp for now. These guys go into the atmospherics. Sure, don't worry, I don't think we will build it in this episode, but we can prepare. So after this one more. And sorry, this is the last one. Then, what else do we need? Obviously, we will need a lot of chips. Basically, I want to do the same thing I did on the other one and have each of these atmospheric units have their own chips. And if we need to change anything on these devices, we can just take out the chip, change it and put it back. We don't need to hunt for any kind of secondary chips. We can change everything in situ. Also, I did print out that analyzer apparently. That's fine. It was just thrown that way. And now we need to make a decision. Where do we want to install this? Well, first things first. We might want to set up the oxygen filtration first. I think having it here will make sense. So we can have the oxygen be stored there. Maybe at some point we will have nitrogen storage there, but it's fine. I think... I suppose we can have just one of these. Also, is that the storm being over or is it just daytime? Whatever. Also, why is... oh, 50 kilowatts. For a second I was talking that it was 50 watts, but no. You know what? We can set up the water generator first and then we can deal with the oxygen. So, where do we want to have this one? Obviously not on this level. On this level, we don't really have enough room. So I think it will have to move up a little bit. Maybe we can have it here instead. I still want to have the level above this one to be a general living space, so we can have a bedroom and dining room and stuff like that, but we can use this one for other stuff. We don't have to use all this for storage. Yeah. Okay, I suppose we can have it on this wall. We can have the radiators outside with the same way we did for the cooling system. Yeah, okay. I suppose we can just start placing stuff down. Now, can we place these on gratings? Let me guess. No, we cannot. Oh, that's fine. We can just place down a couple of frames. So, thankfully we have plenty. Hopefully that will do. If not, we can just move them. So, let me see. I think we will start here with a voltage filtration. Yeah. Input will come from outside. It will also go straight out, and the voltage filtered will be stored here, which means we will need to have a inline tank the same as it was before. Then we will need a... do we want to have a mixer or use the volume pump mixing again? I think volume pump mixing will do just fine. It will be more precise and we can set it to make sure it always have a little bit of extra voltage. So, right. You will give us volume pumps. 2 of these. And do we want to skim off the excess volatiles and oxygen from the combustor output and recycle them. That might not be a bad idea. Also, I've overprinted, but whatever, we will use these. So, if you remember, after the combustor we still had a trace amount of oxygen and volatiles and on the output. So, if we wanted to, we could recycle them, but no, wait, they will be extremely hot, which means if we put them into the fuel mixture, they will automatically combust, so that will not do. I mean, I suppose it's going to be a minuscule amount of oxygen, so I don't think we will lose a lot. So yeah, I think this will do. So this one will go here. It will be a simple T-junction with an inline tank above, so this is where the volatiles will come from. In fact, we can pick up the pipes. Oh, we have the pipes, but we don't have the inline tanks. I will recycle or use these as placeholders for now. I mean, I suppose we can just put insulation on them. I keep forgetting that we have the insulating items now. It's a fairly new addition, but anyways, a T-junction, that will do. So there, so I will turn this into a 111 and the storm is over apparently. That was a bit of an abrupt transition. Anyways, volatiles, input, output, that's fine. This one will go into the H2 combustor, and we need to have the oxygen coming in as well, so I suppose, yeah, here for now. We will decide how this will be dealt with. The pipes, you guys will, yeah, let's just place down as much of them as we can. That will do. And the next one, the H2 combustor. Right. This one will be this. Apparently the output is that way, so I suppose we can do it this way. There. So this one will hook it there and hook in that way. I suppose we can increase the volume of the fuel mixture storage as well, if we wanted to, but I don't think it's going to be necessary. We have 1, 2, 3, 4, 40 liters or something like that, maybe 50. So yeah, this will be plenty of storage for the fuel. So H2 combustor, out comes the water, and this is what we need to cool down. But I believe this one will also give us pollutants, right? Now that the storm is over, I suppose we can check on the original design. Also, we can pick up the power properly now. There we go. Also, before we go, vent the canister. So, I am not sure if the combustor will give us pollutants, but I suspect it will. Let's just check on it. So, there, also the laptop belongs there. So, you. Yes, it will give us pollutants. Okay, so we don't want to cool this one down too much and don't want to overpressurize it either. Which means that we don't want to cool this one. We might be able to radiate it, but I don't think it's going to be necessary. We want to cool the filtration output, only the water. If it's cold enough, it gets shoved into the base. If it's hot, then it will remain outside and gets cooled. So, right. I think... yeah, so this is not going to be in the new setup. It will be only here, and this one will be taken up by 2 ACs. Right, and speaking of water, let me just take a look at the base. It is now 6 liters. So we did make a lot of water, but let's take a look at the base as well. Ah, okay, not too bad. 24.6. In fact, it's older than 25. Not bad. So the water is 33. You know what? I was expecting a lot worse. And the more we have in the base, the easier it will be to keep it cold, basically. Because the amount, 1 liter of very hot water will not heat this up as much as it would if it was less volume. So I think it's going to be better the more we have. Anyways, let me just quickly eat this one. And by the way, in the new base, we have nitrogen, so we supposedly could start planting some soybeans too. I guess we will see. Anyways, I think these are fine. Yeah, let's just pick up this one. So we have checked. We do generate pollutants when we are generating water, so we need to be careful. We don't want to cool down the combustor output too much. We only want to make sure we are cooling the filtered liquids. Okay, yeah, let's just print out a bunch of extra piping. So you give us some extra pipes. I want to see what we are dealing with actually. So insulated piping, but first give us adhesive insulation. So give us 2 of these, and then I will print out a couple of extra insulated utility kits as well. I suppose we will need these eventually, so might as well. For now, just the one. Yeah, after that we can get the pipes. So insulated piping, please. Thank you. While they are printing, I will go upstairs and insulate this one. We need the wrench. Right, so this one will take 2 insulations, right? Yeah. Okay, so now this is insulated. Well, if you spray one time, it will not pollute the base enough, so I think it should be okay. Let me just paint it, you know, consistently. So that should do it. And the pollutants should get lost in the base atmosphere. It gets diluted and it will stop being tracked in a second, I believe. And there we go. Okay, it's gone. It's a little bit of an exploit, but I don't really mind. Anyways, I think, yeah, that's going to be enough. Plenty of piping. Good, good, good. Also, fine. You just go on the floor. So, let's deal with this one first. Let me see. Oh, right. I suppose I could have picked these up, merge it with this one, and that would have painted them, but whatever, no harm, no foul. This one will go that way, this one will go this way, and them together. So fuel mixture storage, combustor, and here we need to have the filtration. So filter this one. I suppose you can go this way. So input, let me see, there's the output, right. Maybe go this way, no. Yeah, I suppose this will do for now. Right, and I want to increase the volume of this one so the combustor can work over time. That should do it. Yeah, I think I will increase the fuel volume as well. And then after this one, the unfiltered output will go out into the atmosphere. So in fact, you can go straight down then make a turn and go outside. But the filtered output, this one, yeah, let's just pick this one up. These are just placeholders. We will turn these into bigger inline tanks eventually. These are just here as a demonstration. So let's have this here, and we will cool this pipe. Let me see, wrench. There. So we'll cool this one with a couple of ACs. So the usual. One AC will cool the actual pipe there, and the second AC will cool the coolant pipe of this one. So you will go there. We need to make sure that this one will go outside into a couple of radiators, and you will cool the input and output on this side. Obviously nowhere near enough piping, but that was expected. I should have left it printing, but oh well. And just keep printing, please. Do we need these pipes anywhere? I suppose eventually, once we get outside and we no longer need to insulate, we can use these pipes, but obviously not inside. So that's fine. Anyways, this pipe will continue this way, and it will have a purge valve. So any kind of liquids that get, or I do believe there was a slight inefficiency in the old setup. Let me see. You are... I don't want to leave this unattended, so I will stop this for now. But we need to check something on the old setup. So, the thing I want to check, whether or not this setup is good enough circulation to keep this one cooled, because I suspect this place is cooling 99.999% from evaporation. I don't think we are receiving any kind of cooling from here. Let me see, 250, 211. Yeah, I don't think this setup is giving us enough circulation to make sure... Well, we might want to cool the liquid pipes instead. And in that case... Oh, wait. Heat exchangers, that's it. Okay, fine. We don't need to circulate, we can just have a condensation valve. We don't need this one. We will just have this one hooked up to the liquid pipes through a heat exchanger and just keep cooling the gas pipes. Yeah, okay. And by the way, what is the liquid amount in the base now? It is 7.13 liters, not bad. Okay, so we will need one heat exchanger as well. Do we want to have a big one or a small one will do? I think a small one will do. If not, we can replace it, it's fine. Okay, now you can keep printing. I will try to remember to come back and check on it in a second. But first, so oxygen will come in through here. That's fine. And that's fine. So this one is the water filter. This one will continue this way through a condensation. Right? This one will need to hook into the gas pipes. I suppose we can go under it. Might be better that way, and just make sure this one is hooked into the waste output of the first filter, first AC. And yeah, this one will go under it. Yeah. Also, you are 14. Okay, stop for now. So yeah, we need to turn that one coming down and go under the AC and hook into that pipe. Okay, should be fairly easy. Let me see. Okay, so we are cooling that pipe. Now we need a condensation valve. Thankfully we have a valve right here. And we will definitely need to have some liquid pipes. Insulated preferably, because this one will still be quite hot before it gets shoved into the base. So first things first. I suppose, yeah, we can have it here. Condensation valve that way. Good. And some liquid pipes. Yeah, now we just need to move these pipes outside. And I think we have the basic setup. Yeah, I don't think we need to have these anymore, so good. So, as I said, these pipes will need to go outside. I will just poke it through for now. We will deal with the radiators later. And this is the unfiltered of the water. I suppose we can just put it into this one. So, just to make sure that we are not going to disturb the oxygen, I will have it come down and then it will go outside. Just poke it through, we will deal with the rest of it outside later. So, you will go ahead and hook into this pipe. You guys lined up, right? Yes, perfect. Okay, you know what? As far as I can tell, this one should work, right? You just start printing out some insulated utility kits. They print for a long time, so hopefully will not overprint too much. So let's just run through this. So volatiles will come in here. It will have its own chip. It will moderate the output, so it should be fine. It will have a active vent input. So this way. Active vent down there. Inline tanks up here. So it will have a pretty sizable input storage. That's fine. 5 megapascal preferably. Here we will have the volatile storage. It will get mixed with the usual mixing that we have implemented for the fuel mixing, basically the same thing. And this time the oxygen will be moderated as well. And here, the combustor, it will operate the same as it did on that one. It will have plenty of storage for the output. Then the filter of the water. Everything else will get shoved out the same way the water filtration goes. That's fine. And the first AC will cool input, output, cooling the steam. Any kind of liquids will condense out into these pipes, and we are cooling the basically coolant, the waste pipe, through this one. Input, output, that looks correct to me, and the waste will be radiated away into the atmosphere. If we really wanted to, we could include one more to make it extra precise, but you know what? I think it's going to be okay. Okay, let's take a look at these. We have plenty. Yeah, 11. More than what we need. That's fine. I'm sure we will make use of them eventually. So, let's go ahead and pick this guy up and replace it with a triple inline tank. There. We will need one here as well. And this one. Good. This one definitely there. Everything else I think is fine. We might want to have this one expanded as well, but it's fine. We only really need to worry about the pressures in here, so it's okay. Right. Yeah, I think this one looks good. If not, I suppose we will troubleshoot it, but in this first glance, this one looks okay to me. Yeah. Okay, do we want to pick up anything? Not really. And we only have 2 of these inline tanks overprinted. Yeah, let's just use them to, let's just print out 1 more and increase the fuel mixture storage as well. Okay, eventually I will try to make sure that we are color coding these correctly. But anyways, the recording is over time at this point, but I think we can go a little bit longer. I will have an active vent there, so we can take care of the volatiles filtering input. This one will, yeah, this will go out with a passive vent, so we can pick up this one. Very good. You can come with us as well. And on that one, we just need the radiators. How many? 1, 2, 3, I suppose. Yeah, make it as efficient as possible. So let's just print out radiators, medium. Copper is also running low. Yeah, we need to go out and mine. In fact, I think the next episode we'll definitely need to have a big mining expedition. In fact, maybe the next episode will be mostly about mining, so we can pick up a full backpack of copper, distribute them in between the different devices, and then gold and iron. So yeah. Anyways, that's 1. After this one, 1 more. We have enough frames, so we can install these pretty much right now. So that will do. Yeah, I think I will just do the same I did with the other radiators. Yeah, they will be floating 1 step away from the walls. I think that will do quite alright. Okay then, so the last one should be good to go at this point. We have 3 radiators, good. Okay, I will go outside, install these real quick. Although first we might want to go and take a sip of water as well. I just realized every time we vent the waste gases into the new base, we are basically transferring gases from here, which is kind of ideal. Anyways, yeah, let's just vent here now. And the water is 9.5, not bad. But first, take a drink. Yeah, coming down from 4-star foods to 2-star foods is a big hit, but we will manage. For now, let's just cook the next batch. Okay, that will do. So, suit is fine, we are fine, we can go and install whatever we have, and then I suppose we can say goodbye. Okay, so we have these all the way up there. Can we reach them? Not really. Okay, not a real problem. We can quickly come inside and pick up a couple of gratings and use them as scaffolding. I believe we need the crowbar to pick them up. So, 1 go up. Yeah, there we go. Just pick up a couple of them so we can stand on something and we can go outside. Okay, now I do believe this is the waste output and the active vent should go right here. So active vent will go exactly. You can go right there. Input, we will limit this to 5 megapascals, so we don't have any condensation, so we don't need to install a liquid drain. We don't really need to have that much throughput for the voltage filtering. And this one is going to be the waste output, which means we need to have the insulated passive vent right here. So let's pick up, let me see, this one. Make sure we don't break open the walls, but oh wait, for those I believe we need the crowbar. So this one should be fine. Yes, and I think that's it. Okay, next up, the radiators. So we can pick this up. Right, so the radiators will come out there, which means we need to have these installed right here and right. These walls are on the outside, which means I don't suppose we can put these. No, we cannot. That's fine. We just need to make sure we put some walls down on the inside, and then we can pick these walls up and place down the radiators. We should have some walls stacked away, right? We have one here and these. Okay, just use this one. So we need to have the radiators right here, right below the actual atmospherics. Double check, I don't want to make another mistake by breaking open the wrong walls. So yeah, below the atmospherics, below the windows. And I do believe we need steel sheets for these. Oh, we have 3, lovely. Yeah, these are temporary. Don't worry about the colors or the patterns. It's fine. So hopefully breaking those open should be safe now. Okay, we'll put this back in a second, but first, the frames. Good, and then the radiators, the same way we did on the cooling setup, so 1, 2, and 3, and that's it. Okay, don't weld them up because we need the steel sheets in a second. So first things first, pick up the frames. They have outlived their purpose. There we go. And now we can put back the walls. And these were, yeah, the flat ones and have the stripe on the top. So this way, I believe. Let's take a look. Yeah, looks good to me. Okay. I think these are fine now. All we need to do is hook them up to the network and there. Okay, before we say goodbye, let me quickly pick up the inside walls and repurpose the steel sheets to weld up the radiators. And before I forget, heat exchanger. Let me see. Heat exchanger, the small one, the kit. Yeah, this will only give us small heat exchangers. Do we want to prepare for big ones, or are small ones going to be enough? I suppose... Yeah, you know what? I think it's going to be enough. If not, then we can put down some extra, but I don't think we need to worry about building big ones. Yeah. Anyways, let me quickly go outside, weld up the radiators, and we'll continue in the next episode. For now, all that is left to say is that thank you for watching. If you like the video, you can leave a like, leave a comment, and maybe subscribe to the channel if you want. If you would like to support me a little bit more, you can do so by clicking the join button and becoming a channel member, which will give you an early and ad-free access to these videos. Once again, thank you for watching and thank you very much for your support. I will see you in the next one. Thank you and goodbye.